Welcome to Basics Revisited. Today we will study quadratic equations step by step. We will cover the basic concept, roots, the formula, the discriminant, graphs, and practice questions from class 9 to competitive level. A quadratic equation is a polynomial of degree 2. The standard form is ax squared plus bx plus c equals 0. Here is not equal to 0. It is called degree 2 because the highest power of x is 2. The value is the coefficient of x squared. It must never be 0. If equals 0, the equation becomes linear, not quadratic. Every quadratic equation has exactly two roots. They may be real, equal, or complex numbers. Let us now identify which equations are quadratic and which are not. Look at each example carefully. X squared minus 5x plus 6 equals 0. This is quadratic. A equals 1, b equals minus 5, c equals 6. 2x squared minus 7x equals 0. Here c equals 0, but a equals 2, so it is still quadratic. C being 0 is allowed. X to the power 4 minus 5x squared plus 4 equals 0. We put t equals x squared, and it becomes quadratic in t. This is a very useful technique. This last equation has a equals 0, so it is linear, not quadratic. Always check that it is not 0. A root is a value of x that makes the equation equal to 0. If alpha is a root, then a alpha squared plus b alpha plus c equals 0. Roots are also called the zeros of the polynomial because the polynomial becomes 0 at those values. To verify root, substitute the value into p of x. If the answer is 0, it is a root. For p of x equals x squared minus 5x plus 6, p of 2 equals 4 minus 10 plus 6, which is 0. P of 3 equals 9 minus 15 plus 6, also 0, so the roots are x equals 2 and x equals 3. Vita's formulas give us a sum and product of roots without even solving the equation, if alpha and beta are the two roots. Sum of roots alpha plus beta equals negative b over a. Please write negative b. This negative sign is the most common mistake made by students. Example 2x squared minus 7x plus 3 equals 0. Sum equals 7 over 2, which is 3.5. Product equals 3 over 2, which is 1.5. To form a quadratic from known roots, write x squared minus the sum times x plus the product equals 0. We now derive the quadratic formula using the technique of completing the square. Watch each step carefully. Step 1. Start with ax squared plus bx plus c equals 0. Step 2. Divide the entire equation by a. We get x squared plus b over times x equals minus c over a. Step 3. Add b over to a whole squared to both sides. This completes the square on the left side. Step 4. The left side becomes x plus b over 2a whole squared. The right side becomes b squared minus 4ac all over 4a squared. Step 5. Take the square root of both sides and solve for x. We now have the quadratic formula. The quadratic formula is x equals minus b plus or minus square root of b squared minus 4ac, all divided by 2a. Memorize this formula completely. This formula works for all quadratic equations, without any exception, whether roots are rational, irrational, or complex. The expression b squared minus 4ac under the square root is called the discriminant. We write it as capital D. D tells us the nature of roots without solving the full equation. This is very powerful. The discriminant D equals b squared minus 4ac. There are exactly 3 cases. Case 1, d greater than 0, gives 2 distinct real roots. The parabola crosses the x-axis at 2 different points. Case 2, d equals 0, gives 2 equal real roots. Both roots are the same. The parabola just touches the x-axis at 1 point. Case 3, d less than 0, gives no real roots. Roots are complex numbers. The parabola does not touch the x-axis at all. Look at this graph. The parabola p of x equals x squared minus 5x plus 6. D equals 1, which is greater than 0. Notice the 2 blinking circles on the x-axis. The blinking red circles mark the 2 roots, x equals 2 and x equals 3. These are exactly the points where the parabola crosses the x-axis. When d equals 0, the parabola touches the x-axis at exactly 1 point. For p of x equals x minus 3 whole squared, the vertex sits directly on the x-axis. The single blinking circle shows the repeated root, x equals 3. Both roots are equal to 3. When d is less than 0, the parabola floats entirely above the x-axis and never touches it at all. For p of x equals x squared plus x plus 1, d equals minus 3, which is negative. There are no real roots. Roots are complex conjugate numbers. Here is the complete picture of all 6 cases. The sign of A determines whether the parabola opens upward or downward. The sign of D determines how many real roots exist. Study each case carefully and memorize this table. A cubic polynomial forms an S-shaped curve. It can cross the x-axis up to 3 times. Here p of x equals x minus 1 times x minus 2 times x minus 3. The 3 roots are 1, 2, and 3, shown by blinking circles. A cubic always has at least 1 real root, because complex roots come in pairs, so a cubic has either 1 real root or 3 real roots. A degree for the quadratic equation is solved by putting t equals x squared. For x to the 4 minus 5x squared plus 4, substituting t gives t equals 1 and t equals 4, then x equals plus or minus 1 and plus or minus 2, 4 roots total, all shown with blinking circles. Method 1 for solving factorization by splitting the middle term. We solve 6x squared plus 7x minus 3 equals 0. Step 1. Find 2 numbers p and q, such that p plus q equals 7, and p times q equals 6 times minus 3, which is minus 18. Step 2. The numbers are 9 and -2. Check. 9 plus -2 equals 7. Correct. 9 times -2 equals -18. Correct. Step 3. Rewrite as 3x times 2x plus 3 minus 1 times 2x plus 3. Take out the common bracket, 2x plus 3. Step 4. The roots are x equals 1/3 and x equals -3/2. Practice questions, Class 9 and Class 10 level. Question 1, Class 9. Solve x squared minus 7x plus 12 equals 0. Factorizing gives x minus 3 times x minus 4 equals 0. Roots are x equals 3 and x equals 4. Question 2, Class 10. Find k if x squared plus kx plus 9 has equal roots. Equal roots means d equals 0, so k squared minus 36 equals 0, therefore k equals plus or minus 6. Question 3, Class 10. Solve 2x squared minus 5x plus 2. D equals 9. X equals 5 plus or minus 3. All over 4. Roots are x equals 2 and x equals 1/2. Practice questions, Class 11 and Class 12 level. Question 4, Class 11. For roots alpha and beta of 3x squared minus 5x plus 2, find alpha squared plus beta squared. Using the identity, the answer is 13/9. Question 5, Class 12. Solve x to the power 4 minus 10x squared plus 9 equals 0. Put t equals x squared. Roots are x equals plus or minus 1 and x equals plus or minus 3. 4 roots in total. Competitive level questions. Question 6. For what values of m does mx squared plus 2x plus 1 have real roots? D must be at least 0, 4 minus 4m must be at least 0, so m is less than or equal to 1, and m is not equal to 0. Question 7. Roots of x squared minus px plus q are alpha and beta. Form equation with roots alpha over beta and beta over alpha. The new sum is p squared minus 2q all over q. The product is 1. Answer. Qx squared minus p squared minus 2q times x plus q equals 0. Four key rules that you must never forget. Rule 1. Sum of roots equals negative b over a. Write negative b. Never write positive b. This is the most common error. Rule 2. D greater than 0 means 2 real roots. D equal to 0 means equal roots. D less than 0 means complex roots. Rule 3. Positive parabola opens upward. Negative parabola opens downward. Rule 4. The quadratic formula always works. When factorization is not obvious, always use the formula. Rule 4. The quadratic formula always works. When factorization is not obvious, always use the formula.